Now, a variation of COPP, it is called Control Plane Protection, or CPPr. So it's a variation of COPP, is very similar to it, but allows for better granularity. So what CPPr does is that it's going to split all of the control plane protocols into 3 subplanes, or sub-interfaces, how CISCO calls it. You're going to have the host subinterface, the transit subinterface, and a self-exception subinterface. And now, before we go to the to speaking like which protocols are going to be covered by which subplane or which subinterface, I want you to know that this unfortunately heavily relies on specific platforms. So this may be different across platforms, which what I'm trying to say is that you can never ever go in your network and implement, CPPr, because I stated that SSS, for example, CCNP belongs to the host subplane, maybe in a specific platform, in a specific code that belongs to the transit plane or self-exception plane. In general, there is very few variations among platforms, but there can be variations, and that's important, because if you believe that a specific protocol belongs to the host subinterface and it doesn't, then of course it's not going to work. So then the host subinterface or subplane is in charge with protocols like SSH, SNMP, EIGRP, BGP, and any kind of tunnels terminated on the router, like VPN tunnels terminated on the router. Then you have the transit subinterface or subplane, which is responsible with all transiting traffic, as the name implies, which cannot be self-switched for whatever reason, like for example a transiting GRV tunnel. So there are platforms that they do everything, for example in hardware or in Ceph, but they cannot offload and Ceph a GRV tunnel, for example. So a transiting GRV tunnel may be process switched by specific platforms, which means it's going to belong to the transit subinterface or subhost. And then we have the self-exception, which is in there we're going to have protocols or traffic that is usually self-switched, but exception occurs, like for example when fragmentation is being needed. So in general, an IP packet which transits the router is going to be self-switched, but because it has to be fragmented, then that's a self-exception, because only the CPU can do the fragmentation. So there we go, that's a self-exception. And in here we're going to have common protocols, which are handled directly by the interface driver, not by the CPU directly, which is going to be traffic like non-IP, which is ARP, CDP, and LLDP, or IP traffic like LDP or OSPF. So based on which protocols you want, based on what protocols you want to just block, not be able to be received by the CPU, or which protocols you want to limit the number of packets that can be received by the CPU, then you have to go ahead and configure a CPPr and do that configuration under the host subplane, under the transit subplane, or the self-exception subplane. So you're going to in general use CPPr because it is better, it offers better granularity. Otherwise the configuration is going to be the same as COPP. So CPPr also makes use of MQC syntax with class maps, policy maps, and service policies. It's just a matter of where do we enforce the policy. While in COPP you're going to enforce the policy globally, in CPPr you're going to enforce the policy under the host subplane or the transiting subplane or the self-exception subplane, depending on which protocols you have matched, and depending on to which subplane is that control plane traffic being associated with. Is it associated with the host subplane, with the transit subplane, or the self-exception subplane? Now, as you see, the host subinterface is going to be also responsible for the management protocols, because they have SSH, SNMP, also TACAX is going to be in there, or Radius.